Okay, so we're going to do the odds of the review packet. Or I'm sorry, we're going to do the evens of the review packet. I did the odds in the other video. I actually did number 2 when I did the odds video, so I'm not going to redo that. If you need to see number 2, just go back to the video that was actually on the odds. So we'll start with 4. And so this you should know. Looks like this. 1, -1. It actually almost looks like our signum function from last year, except there is not a circle at 0, 0. So as x approaches 0, limit does not exist, because from the left and from the right, we're not approaching the same y value. So limit from the left is not equal limit from the right. 1 from the left. Okay, so this is where there's a vertical asymptote at x equal 1. So we are going to have to do our number line. Put 1 on there. Put our factors down. We're going to partition, so we're going to get a number to the left of 1. So let's say I was at 0.999. So we usually just want to go slightly to the left. Because we're approaching 1, so we're getting very close. So when we're doing limits, we just want to go slightly to the left. That would then be positive. This would be negative, which is overall negative. So that means the graph shoots off to negative infinity. To the right, let's say I picked 1.001. That would be positive. That would be positive. That means that would shoot to positive infinity. So they're asking, what is the limit as x approaches 1 from the left? If I'm coming from the left of 1, that's where I'm at negative infinity. Next one's just going to be a plug it in. Oh, x approaches 5, not x approaches 3. What am I doing? Okay, so it's x. It's hard to see on this. Okay, so 15/26. Next one is just that rule. So it'd be 3/2. So we would say sometimes limit as x approaches 0 of cx over a tan bx, right, would just be c over ab. 12 is just to plug it in. 0 plus 3 times 0. That is 0. 14, plug it in, pi over 2, sine of pi over 2. Sine of pi over 2 is 1. So that would just be pi over 2. This would be sine of 2 times pi over 4. You have to simplify that, get it to one single value. So that's sine of a pi over 2, which again is 1. Pi cos pi. Cos of pi is -1. So this would be a negative pi. We saw a few of these with the odds. This is where you multiply by the conjugate. So it's the limit as x approaches 9. Reason we do that is if we were plugging in, we would get 0 over 0, which is the indeterminable form. So where we have the two radicals, we're going to FOIL. 9, outers, inners cancel. Last give me minus x. Then I leave wherever I have the radical and the non-radical, I leave it factored. And that's because something will cancel, and then I can plug in. right, 22 goes to a limit at infinity. So I'm going to say the limit as x approaches infinity. I'm going to divide everything by an x cubed. So limit as x approaches infinity of 1 over x minus 25 over x cubed, 3 minus 5 over x squared. All right, so basically, when I do the limit as x approaches infinity, that goes to 0, that goes to 0, that goes to 0. So we have 0 over 3, which is 0. 24, limit as x approaches infinity, divide everything by x. So that's limit as x approaches infinity of 3 plus 2 over x, 4 minus 1 over x. Constant over a really big number goes off to 0, so we have 3 over 4. You can also shortcut it if you want to and just divide everything by x. So that would be 2, that would be 1, that would be 3 over x. So I'm kind of okay if you skip that step. Limit as x goes to infinity of that is 0, so you have 2 over 1, which is 2. So if we want to use that same method in the next one, divide by n, that would just be 2, divide by n, that would be 1. So we're dividing everything by n. And then we're going to basically say, okay, that goes off to 0, that goes off to 0, negative 2 over 1, which is negative 2. So again, a constant divided by a really big number will go off to 0. Limit as x approaches negative infinity. So still same process. We're going to divide everything by x squared. So that'll leave an x. This will be 15. If I divide that by x squared, I'll have 15 over x. 2 over x squared. Divide by x squared, and I just get 2. So what I want to think of, that goes to 0, that goes to 0. So I want to think what would happen if I had the limit as x approaches infinity, negative infinity of x over 2. So if I plug in negative infinity, it'd be negative infinity over 2, which is going to go to negative infinity. And all right, this one's got a lot of limits at infinity problem. Okay, so we divide everything by x squared here. That's x, 1 over x, 5 over x squared, 1 plus 1 over x squared. So that goes to 0, that goes to 0, that goes to 0. Plugging in, it would just be infinity over 1, which is infinity. Okay, 34. Is f continuous at x equals 0? Explain why or why not. Okay, so in order to be continuous at x equals 0, first of all, limit needs to exist at x equals 0, and that limit needs to equal f of 0. So let's see. I'm going to do the limit of f of x as x approaches 0 from the left. Right, because to tell if the limit exists at 0, you have to do the limit from the left, limit from the right, make sure they're equal. So 0 from the left is this interval. So I plug 0 into here, get -3. If I do the limit of f of x as x approaches 0 from the right, now slightly to the right of 0 is this interval. Okay, so limit of f of x as x approaches 0 does not exist. So no, f is not continuous at x equals 0 because the limit of f of x as x approaches 0 does not exist. So that fails one of the parts of the three-part definition of continuity. If the limit does not exist at 0, then it cannot be continuous at 0. 36, find a and b values so that f of x is continuous everywhere. Okay, so then we know the limit of f of x as x approaches 2 from the left has to equal the limit of f of x as x approaches 2 from the right. So 2 from the left here, 2 from the right is this one. So it'd be a times 2 plus b. You'd be plugging in 2 for x. Also, to be continuous everywhere, there cannot be a break at 4. So the limit of f of x as x approaches 4 from the left has to equal the limit of f of x as x approaches 4 from the right. So 4 from the left, to the left of 4 would be this interval. So that'd be a times 4 plus b. The right would be here. So that's 4 squared minus 2. 4a plus b. 16 minus 2 is 14. And now we want to figure out what the common solution is to the system of equations. So if I subtract, I will get 2a equals 8, right? The b's will cancel. So a is 4. And then to get b, you could plug into any of the original. So let's say I said 2a plus b equals 6. I know a is 4. So b would be -2. Finally, does the function f of x equals arctan x minus 1 plus x cross the x-axis between x is 0, x is 1? Explain. All right, this is our IVT. So f of 0, arctan of 0 minus 1 plus 0. Arctan of 0 means where is tan 0? Well, tan is 0 at 0 degrees or 0 radians. So this is -1. F of 1 is arctan of 1 minus 1 plus 1. All right, minus 1 plus 1, that cancels to 0. Arctan of 1 means where is tan 1? Well, tan is 1 at pi over 4. So this is negative, meaning less than 0. This is positive, meaning greater than 0. We have that sign change. So yes, since f of x is continuous because it's the difference between an inverse trig and polynomial function, right? So going back to the difference between inverse trig, polynomial, right? Therefore, by IVT, so since we know it's continuous and there's that sign change from a negative y value to a positive y value, therefore by IVT, f of x has a 0 between x equals 0 and x equals 1. So somewhere between those x values, it has a y value that's 0. All right, that's it for the evens.